Hey Parks Canada, my name's Joe Moak and I'm a member of Group 4D. This is our proof of concept, our final prototype for a T-bar puller. Group 4D just wants to take a moment to thank Parks Canada for this amazing opportunity. We're super grateful for all the work we've done so far and all the experiences we've gained while doing it. Our group is made up of myself, Joe, Sam, Menna, Kelenna, and Nathan. During this presentation, we'll be taking a look at a recap, so things we learned after our initial prototype and what we learned after our discussion with Parks Canada, our initial prototypes and designs, so things that worked and didn't work, our final prototype, which comes with some CAD modeling, some dimensions, list of materials, as well as limitations of our chosen design, our results, our budget, and finally, our conclusions and things to consider moving forward. When starting on our final design, there were a couple of things we were taking a look at that did not change. We knew the requirements needed from Parks Canada and what needed to be incorporated into the design no matter what we chose, which include reducing backstrain, not damaging the surrounding habitats or environment, limiting noise, being efficient and light for portability, as well as being easy to maintain or to produce. After our discussion with you guys, we learned a couple of things to incorporate into our next few designs, um, including the fact that multiple surfaces where the T-bars are planted are not flat. So how can we create a device that will be able to operate on uneven terrain? We learned that multiple of the operators of this device will be either older or younger or all sorts of ages, and so that any sort of lever or pivot that we use may have to be accessible to all sorts of users. The designs we presented were not portable enough as per what you guys were looking for. So we knew that we would have to continue to iterate and simplify any designs that you guys liked. We knew that our designs had the potential to work, however, it needed more work moving forward.
After our meeting with Parks Canada, we began working on our first prototype. This prototype was made to show that our design would be functional and meet all the requirements we had in place. This prototype had a base that was 25 inches long and 16 inches wide, and our pivot was 12 inches from the center to the floor. The lever arm was 5 feet long with 1 foot on the short end of the pivot and 4 feet on the long end. So as you can see here, this was our first prototype after we had finished designing it, and it is a bit bulky, which is not really ideal. It wasn't convenient to carry around, but it did end up working, and I'll show you a quick video here.
Straight as you can. Yeah, there you go. So we lost force.
So as you saw in the video, although it did work, our design was a bit bulky, and we found that it wouldn't be very portable. It wouldn't be nice to carry around all day, working on the beach and such. There was a bit of loss in sideways movement. It wasn't as stable as we intended for it to be, and you can kind of hear in the video there's a bit of creaking because it wasn't as sturdy as we were hoping it would be. Also, our connection to the T-bar was very time consuming and inconvenient since we just had a pin and we had to tie it and move it each time we wanted to move the T-bar. So it wasn't the most convenient, and it was also kind of difficult to balance on the lever arm. since it was just a 2x4 and we didn't really have like an actual spot, like a foot pedal or anything like that. And we decided for our final prototype, we're just gonna keep the lever arm as a detachable piece from the base, just to make it easier to carry around.
Final prototype. To the left, you can see a picture of what we call our base. It has a U-shaped component on top, which is our pivot. And to the right, you can find the complete assembly of the lever arm with the base. As you can see, attached to the lever arm is a foot plate, and this plate was made available so that the user can easily apply pressure to the lever arm. So the following iterations were made to create our final prototype. The foot plate was added, and this was so that the user could apply pressure to the lever arm and still be stable. Um, the base design was changed, the size was modified, and we made this decision to increase the compactness and structural integrity of the base so it could support the large weight of someone applying pressure and lifting a T-bar. The length was changed as shown, and the width was also modified in this way. Notice that the top width was changed by a lot, it was reduced by a lot, and because of this, we had to change our pivot design uh, for the lever arm. So the dowel that was attached to the lever arm was shortened in order to accommodate for that change in width for the top of the base. These are the dimension drawings depicting our final prototype. It shows the dimensions for each component, and it just goes to show how much detail was put into dimensioning and understanding the structure of this final prototype to make it more structurally sound and reliable. So here we can see the bill of materials. The bill of materials depicts the material used for each component, the name of the component, the part number we give it, the quantity, and the dimensions of each part. The bill of materials will be very useful if someone plans to replicate a design in the future. And the results of our final prototype can be seen in this video of my colleague Sam. He was pulling out a T-post in this video. The T-post is, as you can see, really deep into the ground, about over 2 feet deep into the ground. And Sam is going to pull this T-post out with relative ease using a lever. And you can also see how compact that base is in this picture or in this video. And the compactness helped to make it so strong that we did not hear any creaky sound from the base in our trials. It's also important to note that we made our T-post puller to be foot operated to reduce back strain because you can apply a lot more effort with your foot, with your lower body, and you also strain your back a lot less. So let's watch this. So here you can see Sam has pulled out um, about a foot of the T-post, maybe more like 6 inches, and it's also important to note that the T-post does not have to be pulled out completely by the lever, but that initial uh, pull can make it really easy for the post to be removed, that someone walking on it can easily lift it out with their own hands. Thank you.
Hello, Parks Canada. It's Sam here again, and I'm going to talk to you a little bit about our budget. Having produced this prototype, totaling up the materials used and an approximation of the time we believe it would take to reproduce, we believe that it would be about $150 to produce one of these units. So breaking that down, we have materials, hardware, and labor. Uh, just having priced off-the-shelf lumber from Kent and Home Depot, we have totaled up to be about 1550 cost of lumber after tax. As you see, we have some pieces listed at only using half of a length. That's the total amount of that type of material used, and that way, if you were to make another, you would already have the exact amount you would need to make that portion of the second. Hardware, we've allowed $10 to $20. Producing one of these, if you're buying items in bulk, you get a better cost. You may already have some of this around, saving on upfront cost. Labor, the bulk of the cost here, we assume about 6 hours, especially to build the first one, to build, paint, or seal it and test. As a person gains practice, I believe that can be greatly reduced. Risk management and safety. So this is pretty much the same as the last video. We want people to watch out for pinch points around the base of the lever, don't want them falling over, or slamming the lever down onto someone's foot. Therefore, safety with steel-toed boots and gloves, spatial awareness, proper lifting form, don't hurt your back, and could be awkward to get your foot up depending on onto the platform, depending on how you have it set up or the area that you're working in. So a walking stick or some form of prop for balance, like a shovel handle or another T-bar that's already been pulled out of the ground.
Hi guys, I'm Nate, and I'm here with the conclusion and the future considerations portion of this presentation. So to begin, through a variety of research, discussions, sketching, prototyping, and iterations, the group was able to create a foot pedal design to pull out T-bars that was fully functional, and we were really happy with that. So if you can see here on the left, we started with our initial sketch once we decided to go with the foot pedal design, which moved into our initial prototype here on the right. Some things needed to change, so we moved into a CAD design, trying to make the base a little bit smaller and a little bit more portable. And we were happy with that, so we moved into our final prototype here on the right. So a few limitations we had was, first of all, the materials. So the final prototype that I just showed you, that was meant to be manufactured with 1-inch square steel tubing for the base, as well as 2-inch square aluminum tubing for the lever arm. Using metal would have provided a little bit more strength, but it just wasn't manageable or feasible at this time, as there wasn't the availability to make this work in the engineering building, but we were totally okay with that. So a few things that were also some limitations that we could recommend was using different nails or screws with shear strength, like a JRK screw, because we were currently using deck screws, which aren't the strongest option out there. JRK screws would be a little bit more expensive, but it would be worth it in adding strength, as well as wood glue could be put in the joints for increased joint strength. Finally, for the footplate, we used plywood, but to make this a little bit cheaper, you could use 1x4-inch lumber. So a few recommendations. Again, the design was made to be made out of metal for durability and improved joint strength, so we would definitely recommend that, as well as a possible adjustable height. So this would be better for a wide range of users, as sometimes it's difficult to get your foot on top of the lever when it's at a steep angle. So if you can make an adjustable height, then it would fit more people and be more effective. And finally, more efficient T-bar attachment, one that was potentially self-adjusting with a quicker setup. So we went with this first option here. It's a bolt and pin. The reason we went with that, it was the simplest at the time, and it always worked. If we had more time, we would likely move into a chain wrap or a wedge card, as you can see here. Both of those provide kind of a ratchet type function, which would be more effective for the user. However, given the time, just wasn't feasible. So, of course, we've got to give thanks to Epi, our good friend, Andy's golden retriever. Without her moral support, we wouldn't have gotten to this point. And lastly, a big thanks to you guys over at Parks Canada for giving us this experience. We had a lot of fun and we learned quite a lot throughout this process over the past couple of months. And we hope to get the chance to work with you guys again in the future. We had a lot of fun and learned a lot. So thank you guys.